Hi everyone, welcome to day 1 of limits. Today's learning target is I can define and find limits. So let's define what a limit is. When we write the limit as x approaches a of f of x is equal to L, we mean that f of x gets arbitrarily close to L as x gets arbitrarily close but not equal to a. And we're going to talk about a few cases today. So case 1 is f of x is equal to x cubed minus 1 over x minus 1, where x cannot equal 1. Obviously, x cannot equal 1 because it would make the function undefined. So why don't we take this f of x and let's factor it. So if you notice, I did factor it, x minus 1 times x squared plus x plus 1 over x minus 1. Notice that the x minus 1 and the x minus 1 cancel out. That means I have a point of discontinuity at x is equal to 1. Okay? Now it's asking us what happens as x approaches 1 from the left and from the right. So if you notice, take a look at our table. We have x values such as 0.75, 0.9, 0.99, 0.999, 1, 1.001, and 1.01, 1.1. So these are values that we want to figure out if it's a particular number that from the left side and the right side it's approaching. So I would use my graphing calculator to input these x values into this function. I did so. And notice I have f of x is equal to 2.31, 2.71, 2.97, 2.99, approaching from the left, from the right, 3.003, 3.03, and 3.3. So what number is this approaching? We can obviously see that it's approaching 3 from both the left and the right. So if I were to write this down, therefore, the limit as x approaches 1 of f of x, which is x cubed minus 1 over x minus 1, that's going to be equal to 3. And that's our first case where we would look at a table to see what number the value is approaching from left and right. Next, we have sometimes we can find a limit by just plugging in the number we are approaching. For example, the limit as x approaches c of f of c is equal to L. So let's take a look at the first example and find the limit. The limit as x approaches 2 of the function x squared plus 3 is equal to. I take this 2 and I substitute it in for the x. So 2 squared plus 3, that's 4 plus 3, which is equal to 7. So the limit as x approaches 2 of x squared plus 3 is equal to 7. You simply substitute the value in. Why don't you take a look at the next example? Evaluate the function at several points near x is equal to 0 and use the results to find the limit. The limit as x approaches 0 of f of x is equal to x over the square root of x plus 1 minus 1. So take a moment to fill out that table and to determine what the limit is as it approaches 0. Pause the video if you need. Here is the table filled out. If you notice, where is it approaching from the left and from the right? It appears to be approaching 2. So that is the limit. Next, we're going to look at case 2, which are 3 particular types of limits that fail to exist. Let's look at the first, behavior that differs from the left and from the right. So let's take a look at an example of the limit as x approaches 0 of the absolute value of x over x. So I'm going to quickly graph that. So let's look here. I want to find the limit as x approaches 0, and if you notice there's a little subtraction sign on the right of the 0, that means as it's approaching from the left. So notice here, As I'm approaching the function from the left, which this is the left-hand side, it's approaching -1. Whereas here, the limit as x approaches 0 from the right, here's the right-hand side. Where am I approaching? 1. Notice they are approaching two different numbers from the left and from the right. Therefore, the limit does not exist since the limit from the left does not equal the limit from the right. So be careful and always look for these symbols, and it tells you where to look from the left and look from the right. They have to be equal to the same number in order for the limit to exist. If anybody of you have seen Mean Girls, one of the parts in the movie is she says the limit does not exist, and this is one example of it. In case 2, we have unbounded behavior, and our example is the limit as x approaches 0 of 1 over x squared. So let's graph 1 over x squared. And if you notice, as we approach 0, it seems to be going to infinity. So since f of x approaches infinity, as x approaches 0, the limit does not exist. Again, notice they're going up here. Why don't you take a look at number 3, oscillating behavior? Use your calculator to see what the limit as x approaches 0 of sine of 1 over x is. Pause the video now. If we were to graph sine of 1 over x, we would see this below, where it oscillates between -1 and 1. If it goes back and forth between -1, 1, -1, 1, the limit does not exist. Next, we want to summarize when the limit does not exist. So the limit does not exist when f of x approaches a different number from the right side of c than it approaches from the left side. Second, f of x increases or decreases without bound as x approaches c. And the third, f of x oscillates between two fixed values as x approaches x. Next, we have 6 practice problems of finding the limit. So why don't you pause the video and take some time to see if you can find the limits of these functions. Let's take a look. So for number 1, the limit as x approaches -3 of x squared plus 7x plus 12 over x squared minus 9. I'm unable to substitute -3 into x because that would make the denominator 0, make it undefined. So instead, I factored. And when you factor, cancel out the two binomials that match, and then substitute the -3 in, and I get -1, 6. Number 2, I substituted -1 in for x and got -4. For number 3, I substituted 0 in for x. E to the 0 is 1, sine of 0 is 0, 1 times 0 is 0. Number 4, I factored again because if I were to substitute, it would make the denominator undefined. Cross out the binomials that match. Then I substituted -2 minus 2 is equal to -4. Number 5, I could have substituted in 0 for x, but remember you can't have a negative underneath a radical, so that limit does not exist. And then finally, for number 6, again, I couldn't substitute 2 in because that would make the denominator undefined. So instead, I could either, I factored and I substitute in, and I got 5 to be the answer. If you have any questions, please feel free to message me on Teams. Hope this was helpful. Have a great day.